but good afternoon, everyone. So I will give this presentation instead of Isabel. And as Marco already introduced this morning, the inventory, I will go quite quick, let's say, through the main part and the main construction. So the actual inventory is taking into account data from 24 European countries. The data were provided by 15 AFG National Association, and then as a Geological Survey, we took care of other 8 countries as UK, Sweden, Germany, Slovakia, Swiss, Croatia, Denmark, and Cyprus. So what was required for the inventory? Actually, the basics, so the name, the location, the commodity, and then the basic geological information such as the deposit type and the genesis, if possible. And also, if there is a present-day ownership, or if the mine is closed, if it is still active, or if there is still some ongoing exploitation or is planned for the future. And then whatever other additional information that could be gathered. So this is the final, the actual number of entries that is in the inventory. So we are at the total of 11,678 mines. And it's a very nice number. I'm very happy about this result. And you can see that the number of entries is varying a lot between all the countries. There are many, let's say, we have 4 examples of huge amount of data. We have France, Italy, and UK that have quite a lot of entries. And what's the reason for these huge differences with all the other European countries? For instance, for France, at the beginning we had only 165 entries, and then we implemented all the data from the Mirror4You database. For what regards Italy, it's because the database of the National Council has all this kind of information. Mainly, you will see that the database is not complete because they take into account only the location, the commodity, and the deposit type. So we just have those basics. For the UK, we used we did another approach. So we developed, in the last row, developed a new approach through the web crawling. So basically, we launched this web crawler that gathers automatically information on the internet, on the web, through certain queries, such as the name of the mine, the location, and all the type of information related to the name of the mine. Then once we gather all the data from all the countries, we needed to homogenize all the information. So all the commodities were listed after the desired code list. And then we needed to have a computation for several entries. In this case, is explaining the water table. So as UNEXMIN, it was developed for flooded mines, we need to know what's the level of the water inside the mines. So in some cases, this number was already given at the beginning when the other association gave the data. Most of the time, we had no information. So we developed this approach. It's an estimation, so be kind on this data. Basically, we did a computation through gauges between the location of the mine, the location of the nearest river point, and through a DEM processing, we kept the altitude of the nearest river point. So as you can see in the sketch, technically the river should fill the mine, and the water table should be at the same level. Of course, it's not an exact number, because maybe the watering tunnel could be closed, or there could be other options, but still it's something that we can structure. Then for the geology, we took into account 8 main categories of ore group, and then accordingly all the deposit types, such as VMS, MBT, SEDEX. So all the mines are listed through specific deposit type. Then also we did the two computations for the access to the mine. So you will see them later in the database that here in the upper part on the left, that every mine is classified with a distance for the access, if it is a road, a path, or a tertiary path. This is a computation that has been made through OpenStreetMap. Yes, as I said, the commodities were listened after the expired code list, and then we can have a look to the actual database. So we can, you see, so all the mines are actually online. If we can geolocate, so for having information from some mine, we just have to click on the point. So you can see there is a small pop-up window with the basic information, such the name, the coordinates, and the commodities. If we click on the plus, we will have access to the fish of the mine with all the rest of information. So which type of access we have, which mine type, the size. Then of course, if we have other information, they will be listed here, such as the activity status, the level, the reason for the closure, and if there are any other information. And you can see here also the water level. So we can also select the mines for commodities. So if we are interested in cobalt mines, we can just select those. And then if we are interested in some particular deposit type, we take type deposit. We have also another selection. Same things for the ore type deposits, such as magmatic deposits. And here we go. Then we also can have the selection through the flooding. And here you can see that the definition of flooded mines is very variable. For instance, if we select polyflooded mines, you will see that, of course, Finland is polyflooded for its geology. But then it's also really relative to the one that compiled the database. In this case, if we select the potentially flooded, we will have the majority of our areas, as we don't really know the exact information. And yeah, all partially flooded. I mean, usually it's partially flooded is the main entrance. So yes, I think I've finished. If you have a question, I was very